It is a violation to simply use the side screw to tap off a new receptacle without using a pigtail. According to the National Electrical Code, all connections in an electrical box must be made with an approved method, such as a wire nut or a pigtail. Side screws are not intended to be used as a means of connecting multiple wires together, as they can become loose over time and create a potential fire hazard. To properly add a new receptacle to an existing circuit, there are steps to follow. Firstly, turn off the power to the circuit at the breaker panel. Secondly, remove the faceplate from the existing receptacle. Thirdly, loosen the screws on the existing receptacle and remove it from the electrical box. Fourthly, cut a piece of wire long enough to reach from the new receptacle to the existing receptacle. Fifthly, strip the insulation off the ends of the wire. Sixthly, connect one end of the wire to the side screw on the existing receptacle. Seventhly, connect the other end of the wire to the side screw on the new receptacle. Eighthly, push the new receptacle into the electrical box and tighten the screws. Ninthly, reinstall the faceplate on the new receptacle. Tenthly, turn on the power to the circuit at the breaker panel. Let's delve deeper into why pigtailing is important and the proper way to do it. The National Electrical Code, or NEC, sets the standard for safe electrical installations. The purpose of the NEC is to safeguard people and property from hazards arising from the use of electricity. One key aspect is ensuring reliable and secure connections. Simply backstabbing a receptacle or using the side screws to daisy chain power to another device is generally not considered a robust or compliant practice. Pigtailing involves creating a single point of connection for multiple wires. Instead of running multiple wires directly to a device's terminals, you connect them together with a short piece of wire, called a pigtail, and then connect the pigtail to the device. This offers several advantages. Firstly, it creates a more reliable connection. With pigtailing, each wire is securely connected to the others via a wire connector, such as a wire nut or a push-in connector. This reduces the chance of loose connections, which can cause arcing, overheating, and potential fire hazards. Secondly, it simplifies device replacement. When a receptacle or switch needs to be replaced, you only need to disconnect one wire, the pigtail, rather than multiple wires. This makes the replacement process much easier and reduces the risk of accidentally disconnecting the wrong wire. Thirdly, it reduces stress on device terminals. Connecting multiple wires directly to a device's terminals can put stress on the terminals, potentially damaging them over time. Pigtailing distributes the load more evenly, reducing the risk of terminal damage. Fourthly, it improves safety. Pigtailing helps to ensure that all connections are properly insulated and protected, reducing the risk of electrical shock. To properly pigtail, there are a few ways to do it. One way is using wire nuts. Wire nuts are a common and reliable way to connect wires. To use wire nuts, firstly, strip the ends of the wires to be connected, exposing about 3/4 of an inch of bare wire. Secondly, hold the wires together, ensuring that the ends are aligned. Thirdly, twist the wire nut onto the wires, turning it clockwise until the wires are securely twisted together inside the wire nut. Fourthly, tug on each wire to ensure that the connection is secure. Another way is using push-in connectors. Push-in connectors are a newer alternative to wire nuts. They are easy to use and provide a secure connection. To use push-in connectors, firstly, strip the ends of the wires to be connected, exposing about 1/2 inch of bare wire. Secondly, insert the wires into the connector, making sure they are fully seated. Thirdly, tug on each wire to ensure that the connection is secure. It's also vital to select the right size wire connector. Using the correct size wire connector is crucial for ensuring a secure and reliable connection. Wire connectors are typically color-coded to indicate the range of wire sizes they can accommodate. Refer to the manufacturer's instructions to select the appropriate size wire connector for the wires you are connecting. Here is the proper way to add a new receptacle to an existing circuit using pigtails. Firstly, turn off the power to the circuit at the breaker panel. This is a critical safety step. Always verify that the power is off using a non-contact voltage tester before proceeding. Secondly, remove the faceplate from the existing receptacle and unscrew the receptacle from the electrical box. Carefully pull the receptacle out of the box, being mindful of the wires connected to it. Thirdly, identify the wires connected to the existing receptacle. Typically, there will be a black wire, which is the hot wire, a white wire, which is the neutral wire, and a green or bare copper wire, which is the ground wire. Fourthly, disconnect the wires from the existing receptacle. Use a screwdriver to loosen the screws on the receptacle terminals and carefully remove the wires. Fifthly, prepare the pigtails. Cut 3 short lengths of wire, 1 black, 1 white, and 1 green or bare copper. The length of the pigtails will depend on the size of the electrical box and the distance to the new receptacle, but 6 to 8 inches is usually sufficient. Strip about 3/4 of an inch of insulation from both ends of each pigtail. Sixthly, connect the pigtails to the existing wires. Using wire nuts or push-in connectors, connect the black pigtail to the black wire from the circuit, the white pigtail to the white wire from the circuit, and the green or bare copper pigtail to the green or bare copper wire from the circuit. Ensure that the connections are secure by tugging on each wire. Seventhly, connect the pigtails to the existing receptacle. Connect the black pigtail to the hot terminal on the existing receptacle, the white pigtail to the neutral terminal on the existing receptacle, and the green or bare copper pigtail to the ground terminal on the existing receptacle. Tighten the screws on the terminals to secure the wires. Eighthly, run the cable from the existing electrical box to the location of the new receptacle. Use the appropriate type of cable for the installation, such as non-metallic sheath cable, also known as Romex. Secure the cable to the wall studs or ceiling joists using cable staples. Ninthly, install a new electrical box at the location of the new receptacle. The box should be sized appropriately for the number of wires it will contain. Tenthly, run the cable into the new electrical box and strip the outer jacket to expose the wires inside. 11thly, connect the wires from the cable to the new receptacle. Connect the black wire to the hot terminal on the new receptacle, the white wire to the neutral terminal on the new receptacle, and the green or bare copper wire to the ground terminal on the new receptacle. 12thly, connect the pigtails to the new receptacle. Connect the black pigtail to the hot terminal on the new receptacle, the white pigtail to the neutral terminal on the new receptacle, and the green or bare copper pigtail to the ground terminal on the new receptacle. 13thly, mount the new receptacle in the electrical box and attach the faceplate. 14thly, carefully tuck the wires into the electrical boxes, ensuring that they are not pinched or damaged. 15thly, reinstall the existing receptacle in its electrical box and attach the faceplate. 16thly, turn on the power to the circuit at the breaker panel. 17thly, test the new receptacle to ensure that it is working properly. Use a receptacle tester to verify that the wiring is correct and that the receptacle is properly grounded. Additionally, there are important safety tips to consider when working with electrical wiring. Firstly, always turn off the power to the circuit before working on any electrical wiring. Secondly, use insulated tools to prevent electric shock. Thirdly, wear safety glasses to protect your eyes from flying debris. Fourthly, follow all applicable electrical codes and regulations. Fifthly, if you are not comfortable working with electrical wiring, hire a qualified electrician. Ignoring these rules can cause harm to life and property. The National Electrical Code is not just a set of guidelines, it is the standard for safe electrical installations. Compliance with the NEC is essential for protecting people and property from electrical hazards. Failure to comply with the NEC can result in fines, penalties, and even legal liability. Moreover, it can increase the risk of electrical fires, shocks, and other hazards. Therefore, it is crucial to understand and follow the NEC when working with electrical wiring. The NEC is updated every 3 years to reflect changes in technology and safety practices. It is important to stay up to date on the latest version of the NEC to ensure that your electrical installations are safe and compliant. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for all aspects of electrical installations from the service entrance to the branch circuits. Some key sections of the NEC that are relevant to receptacle wiring include Article 210, which covers branch circuits, Article 250, which covers grounding and bonding, and Article 406, which covers receptacles, cord connectors, and attachment plugs. It is important to consult these sections of the NEC when installing or modifying receptacle circuits. In addition to the NEC, there may be local electrical codes and regulations that apply to your area. These local codes may be more stringent than the NEC, so it is important to be aware of them and comply with them. You can typically find information about local electrical codes and regulations from your local building department or electrical inspector. The importance of using a qualified electrician cannot be overstated. Electrical work can be dangerous, and it is important to have the knowledge and skills to perform it safely and correctly. A qualified electrician has the training, experience, and tools to handle any electrical task from simple repairs to complex installations. Hiring a qualified electrician ensures that the work is done safely, correctly, and in compliance with all applicable codes and regulations. This can save you time, money, and potential headaches in the long run. To find a qualified electrician, ask for referrals from friends, family, or neighbors. You can also check with your local Better Business Bureau or online directories. When interviewing potential electricians, ask about their qualifications, experience, and insurance coverage. Make sure they are licensed and insured to work in your area. Also, ask for references from previous customers and check them carefully. Electrical safety is everyone's responsibility. By following safe practices and complying with electrical codes and regulations, you can help to prevent electrical hazards and protect yourself, your family, and your property. If you have any questions or concerns about electrical safety, consult a qualified electrician. Some common electrical hazards to be aware of include overloaded circuits, damaged cords and plugs, and wet conditions. Overloaded circuits can occur when too many devices are plugged into a single circuit. This can cause the circuit breaker to trip or, in more serious cases, lead to an electrical fire. Damaged cords and plugs can expose live wires, creating a risk of electric shock. Wet conditions can also increase the risk of electric shock, as water is a good conductor of electricity. To prevent these hazards, avoid overloading circuits, inspect cords and plugs regularly for damage, and keep electrical devices away from water. If you experience any electrical problems, such as flickering lights, tripping circuit breakers, or shocks, contact a qualified electrician immediately. Do not attempt to fix electrical problems yourself unless you are a qualified electrician. Remember, electricity is a powerful force that can be dangerous if not handled properly. The information provided here is intended for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician before performing any electrical work.